Pre-lab video for the lab entitled What Product is Obtained on the Nitration of Methyl Benzoate? And this reaction is an example of a reaction we'll be talking about in the next few weeks, and the mechanism is called electrophilic aromatic substitution, because what we're doing is we're replacing one of the hydrogens on the aromatic ring, or substituting it with a nitro group. And those nitro groups, what you see here where it says meta, ortho, or para, when you have two groups or two substituents on an aromatic ring, their relative position to each other is described using the terms meta, ortho, and para. So when those substituents are in the 1 and the 3 position relative to each other, that's called meta substitution. When they are in the 1 and 2 position relative to each other, that's called ortho substitution. And when they are in the 1 and 4 position relative to each other, that's called the para substitution. And what we are going to see in this reaction is, although we have 3 possible products, we are only going to actually get one of these constitutional isomers. Now, the process of this reaction is pretty simple. This is a microscale reaction, and we're going to use some super high-tech equipment that you can see right here, test tubes, to do the reaction in. So in the first step of this reaction, we are going to place 1 milliliter of sulfuric acid into test tube 1 here. So we'll have 1 milliliter of H2SO4, and then we'll add to that 0.7 to 0.08 grams of methyl benzoate. And all of these test tubes, because as we're doing this, we want to make sure that they're cooled to 0 degrees Celsius, which you can just do in an ice water bath in a beaker. So tube 1, we've got our methyl benzoate, and we've also got that's going to be dissolved in 1 milliliter of H2SO4. Okay, then in tube 2, right here, you're going to have your mixture of 0.4 mils of nitric acid and 0.4 mLs of H2SO4. Now, in order to mix these, it talks in the lab handout about how you want to mix them to make sure that the mixtures are homogeneous and not in 2 layers. Now, when you do that, you might be tempted to just put one finger on top of the test tube and invert it like this. And if you do that, you will be very, very unhappy. So do not do this. I will show you how to mix the reagents when we get to the when we get to lab this week. Okay, so here's what your reaction setup is going to look like. You're going to have a beaker. That beaker is going to be full of ice and water so that you can cool tubes 1 that has your ester and your H2SO4 in it, and tube 2 that has the mixture of the nitric acid and the H2SO4. And then what you're going to do is you are going to take a pipette and you are going to take this mixture and slowly add it to the ester and sulfuric acid mixture so that the reaction can happen. You're going to do this addition with a Pasteur pipette. Now, something very important to keep in mind when you are doing this is how to hold a Pasteur pipette. This is the correct way to hold a Pasteur pipette. The tip is down, and the liquid in the pipette won't get into the pipette bulb. Now, this is the incorrect way to hold a Pasteur pipette bulb. Notice that when you're holding it like this, the liquid is now running down into the pipette bulb. That's a problem for 2 reasons. It contaminates whatever the solution is with whatever is in the bulb. It also destroys the pipette bulb, in this case, especially since you're using concentrated sulfuric and concentrated nitric acid. So do not ever, ever, ever hold your pipette this way. Because if you do, not only will I be upset, Dudley will give you a look. Okay, so now we've got the both of the solutions mixed together. You're going to allow them to react at 0 degrees for 5 to 10 minutes, and then allow them, take it out of the ice bath and allow it to react at room temperature for about 10 minutes. Okay, so now you've got your reaction mixture, and it's been hanging out for about 10 minutes at room temp. And then you're going to have another test tube, and this test tube is going to be about 2/3 full of crushed ice. And then you're going to take a pasteur pipette, which you're handling correctly, of course, and you are going to add a few drops of this mixture to the crushed ice, and you should start to see white crystals forming. Once you start to see those crystals form, then you can add the rest of the mixture to the crushed ice. Once you have done that, then and the crystals have formed, then you can vacuum filter them, and you can rinse them with a little bit of ice cold water and a little bit of ice cold 95% ethanol. And then what you're going to do is you're going to take those crystals and you're going to recrystallize them to purify them from 95% ethanol. Now there's two things I want to go through here. One, I want to talk about this rinsing process with the 95% ethanol and water, and I'm going to go briefly through recrystallization, but you need to watch that video again. At least that's what I gathered from the groans I heard when I heard people talking about recrystallization. Okay, first off, I want to talk about rinsing the solid in a vacuum filtration with a small amount of ice cold solvent. Firstly, you guys need to think about this and get the solvent cooling earlier. A lot of you guys don't think about that until you get to the point of, oh, here I have crystals in a Buchner funnel, I need to rinse them. And you could, for example, that 10-minute period or that 15-minute period while you're letting the reaction happen, you could be setting up your vacuum filtration, you could be cooling your solvent. The second thing that I see when people are cooling the small amounts of, say, water or ethanol that they need to rinse crystals in a vacuum filtration, well, they'll have an ice bath, and then what they'll do, they'll take something like 125 ml Erlenmeyer, or even more fun, a squirt bottle of deionized water, and then what they'll do is they'll just fill that sucker up with like 75 or 80 milliliters of DI water and put it in the ice bath. And this is problematic. Number one, it's way more liquid than you're going to need to rinse your crystals. Also, all the stuff that's here above the ice bath isn't going to get cold. And so when you're adding it, you're not really using cooled solvent. So what you want to do is use a small beaker with a small amount of whatever you're trying to cool in there, or a small Erlenmeyer flask and a small amount of whatever you're trying to cool in there, and then it's going to actually get cold. Okay, so when you're doing recrystallization, one of the things you want to do is you want to transfer the compound that you've isolated by vacuum filtration to an Erlenmeyer flask, not a beaker. Do not do recrystallizations in beakers. Okay, so why am I being so draconian about a beaker versus a flask? Well, if you have a flask and you're heating the solvent, what happens is it comes up and it hits the side, and then it runs back down into the solution, so you don't lose it. Whereas with a beaker, the solvent just very rapidly evaporates out. Also, something that happens is that it's much more easy for when you have an open beaker for your sample to bump and splatter out, whereas you have some protection against that with an Erlenmeyer flask. Don't forget to save a small sample for a crude melting point. Then you're going to boil some of the solvent in a separate Erlenmeyer flask. Add a small amount of the boiling solvent to the flask with the crude compound and then heat that on a hot plate and continue to add boiling solvent until dissolved. I'll give you a hint that this is not going to take a heck of a lot of solvent, so you need to be careful about this. And you always want to use a minimum amount of boiling solvent so that if you add too much solvent, what will happen is that your crystals may not come out of solution. Then, of course, once you have a clear solution with no crystals, it might have color to it, but there won't be any solid in it. Allow it to cool slowly to room temperature, then chill in ice until it appears that it stopped changing, and then you're going to isolate the compound by vacuum filtration, and once again rinse it with a small amount of ice cold solvent. And the solvent is the solvent that you're using to recrystallize, which is the 95% ethanol. I'll mention this really quickly. What's in the pre-lab? Y'all are getting really good at this. That's awesome. You need the reaction, the reactants, and the amounts to be used. You should look up the melting point of all the possible products. Calculate theoretical yields. Spoiler alert here, the limiting reagent is the methyl benzoate. And as always, have a plan or outline for what you're going to do. And that's it. Be sure that you watch the videos on how to handle a pipetter, also on how to do a recrystallization, and of course this video as well. You can rewatch it as many times as you want. All right, that's it. Don't hesitate to get in touch with me if you have questions, and I'll see you in lab next week.